Hello guys, so the deal is that I want to make a small computer for myself because you see in past I had like a Nokia communicator and I fell in love with it, and then netbooks came and the thing was like they weren't as small as they could be. So I bought this LCD, and this is like 2K LCD, and it is exactly pocket size, like you can fit this into pocket. And so I was recently browsing for completely unrelated stuff. Actually, I needed some Raspberry Pi Zeros because I used one in my chicken coop already, so I can SSH into it. Anyway, so I saw that there's a Raspberry Pi 5 now, and it has 16 gigs of RAM. And so I was like, okay, that's usable, especially because this compute module does not have any like I/O stuff on it, and so I bought like a development board, of course, because I don't want to do like things blind. So the only thing is to replicate this I/O board with a bit of customization, I guess. And I have already shown you this exposure unit. Basically the thing is that you print the thing on normal paper, then slap a PCB onto the thing, press the button, and in 60 seconds you have like exposed board, which is very, very nice. But of course, this being inkjet, do you think this will work? No. So I need something a little bit different. Also, what the fuck happened here? I did not update my fill zones, I guess. Anyway, so yeah, other option is to use laser, but you see with laser, I guess laser jet, with laser you get very good precision, but you don't get very good contrast. So what happens is you basically tweak this time. Well, at this temperature and humidity, my table says that I should use 31.678 seconds, so I get perfect exposure of PCB. Fuck that. And so, what better options are there than this? Well, it's this. Well, it's definitely better. You can achieve much greater resolution than even with laser maybe, but the simplicity. This is not as simple as just printing paper and slapping it onto exposure box as a mask. Also, this particular model, it has a large volume because I needed it for things, and it has 8K screen with a resolution of 1 pixel of like 35 micrometers, something like that. Where you need resolution the most is where you do diagonal lines, of course, but even with like low resolution you can do thin lines because pixels are large. But the diagonal lines, I guess, is where it gets you. So this is the board that I have designed. It's really just copied from this. Oh my god, look at the numbers of vias here. I mean, as you can see, my motto is vias are overrated. I have basically 2-layer PCB, and on the bottom layer there are these 2 tracks that I had to route it. I mean, this is not very great, but it's USB, so it will be fine. The obvious difference between this reference board and my board is this is a bunch of I/O ports and this GPIO, which I don't really need. I need PCIe definitely, but I did not route it because it's, I guess, best to start simple. But anyway, so I have one USB here, one HDMI. And this is USB-C for power, and this is USB 3. It's just routed to some connector because I don't really need to use it right now. And even then, it will be probably routed to this style of connector because it would go under batteries to some panel board externally mounted there. Anyway, there's switch, some diodes, some power management for USB and stuff like that. Nothing fancy really. I have used 2 jumpers here in HDMI, but this is on SDI and CEC, so it won't be too horrible to do this. Differential pairs are routed pretty much straight, same for USB. These are, I think, PN swapped, but it's allowed. The little detail I want to mention is that this is 2-layer PCB, and so the track width is huge and the track spacing is tiny. This is, I think, well, I don't think, I know it exactly, it's 140 microns. It's 140 because the printer resolution is 35 micrometers per pixel. 35 by 4 is 140. I mean, you can see it here. I recently calculated it and I had to change stuff because, well, what happened is when I exposed this board and etched it, sometimes you get space of 4 pixels here and sometimes 3, I guess, anti-aliasing here. It jumps basically, and you don't really want to do that. Anyway, so let's print this. Let's switch this to black and white. Okay, so let's print PDF to desktop. Now let's open UVtools. You can get this from GitHub, I think. All links will be in the description, of course, and stuff like that. But the thing with 3D printers, especially mine, is that their file format is not exactly open. Like, I guess this is a bunch of hackers that created this tool and that allows you to do stuff. And so you basically need some, in my case, CTB file for printer, and I have one like this. And I have already modified it, but it doesn't matter. What's important here is that you set the exposure time correctly. In this case it's 80 seconds. Here you can see that I have started to make this with a different process, which is ridiculously difficult and overall ridiculous, but I will cover it as well. And so what you want to do is export layers to images, and you want basically one layer, and yeah, this is fine, this is all fine, and export, yes. And then you want to open this with some editor. GIMP works fine. Now you need to set image print size, and the print size will be defined in millimeters, and it will be derived from this thing, which is 21888. So let's put it here, 18.88. The other value should be obviously correct, and you need to copy resolution in whatever unit. I have moved this PDF into the test folder, and now what you need to do is drag it from here to the GIMP, set the resolution, this is important, press import, and what the fuck, this is incorrect. Okay, I have made a mistake, this now looks correct, so I will do this, and I will align it to this corner, because it should make it easier to align the PCB as well. And what you need now is to do rectangle select, or you can press R key, and I will drag from this corner to this corner. There is probably some tool that makes this easier, but whatever. Then I want to do select grow by, let's say, 10 pixels would be 0.3 millimeters, 0.35, so let's do maybe 10 is fine. And then I do select invert, then I do bucket fill, and with black color I fill everything else. This is mainly because my cuts layer is the same as the copper fill, so I need to do this manually to have some reference where to cut the board, I guess. Anyway, this should be fine. There's a little bit of white area, but I will merge this down, and there is the old PDF, so I will merge this down again. And now I fill this region. Now, when you zoom in, you can see that there is some anti-aliasing. And Well, my intention was to have 4 pixels between differential pairs. Let's see. There are 4 pixels, but the thing is, when I adjust contrast, okay, it shifts a little bit else, but I don't know, is this like nicer? Question is how it will then look on the PCB itself, but I think this is probably fine. I will leave this like this. So now when we've got this, I will export this image to, let's say, override this original, replace, export, yeah. Fucking one more button could be there. Is this green line print boundary? Oh shit, I think we fucked up. Okay, that sounds good. So anyway, we are done. So now we do save as. Let's save this to the same. Let's save this to the same folder, and we'll do, I don't know, and let's call this test. Now keep in mind that other layers are still like old, but this is the one that I want to print, so this should be fine. Let's go over more complicated and ridiculous setup. Let's start up FreeCAD, or I think you can use Fusion for this, I'm not sure. Let's make a new file, and there is add-on with a workspace named KiCad StepUp, which is great if you want to use like your boards in your 3D models. You can use this tool, add tracks. It could be a very intensive loading, it indeed can. And you go to the board, which is this board, and it will start adding tracks. Alright, so tracks are added. This is still incorrect, but never mind that, I did not save the board, I think. So this is the PCB, and there are some things like, for example, copper layer is still like higher, so you need to transform it by, I think, 10 microns or something like that. So this can include even 3D models of the components, so it can look very nice, but basically what you can do is you can like, let's say I don't want bottom layer here. Let's isolate and select, let's say, top zones, and you can extrude it, let's say by, oh, here it is, by 10 millimeters. And you've got this 3D representation of the zones. Then you can go to the part design. Let's make a new sketch on XY plane, and let's do some whatever rectangle like this. Let's extrude this by, let's say, 6 millimeters. Then let's move this body by 1 millimeter in Z. So you can see how this intersects. And you can go back to the part design, and you select body and then select cutter and press cut, and you wait. Now this can take a very long time, and also this is just one, this is just zones, which is very like simple 3D model, the tracks and paths, and you need to combine these basically, and this can take you hours to really do this way, and still you won't be guaranteed to get good result because, well, Boolean operations in 3D space are messy. So the idea is that you can export this as a mesh and use the slicer that you are familiar with and create basically as if you were normally 3D printing stuff, but yeah, this is not a great way to do this in my opinion. There are other concerns like the... it finally finished. There are other concerns like the precision of this mesh when you export it. Anyway, Now you export this as a mesh, let's say, fine, whatever. Then you can open Slicer, which is glitchy, because nothing else works on Linux. Now you can drag the mesh here, and as you can see, this is how it looks. And you can do like export, and this is basically what would be exposed on the copper. Okay, I have done a bunch of mistakes during the 3D printer file process. Like, I think I had to do convert to, not save as, because then it did not work. And my cat is calling me outside because it's nice outside, and my cat do be like that. So now what you will need, basically, start 3D printer, prepare some poking sticks, because the platform is up there. There is actually the actual platform is removed, but what you need to do is basically do print, then choose your file. I think this was correct. Then when you press print, you need to trigger the sensor manually, or just have it already like this. Then it go up and down, again trigger it, and this will start the exposure, and this is how it looks. Now if I put paper in here, this is about the contrast you will get. Now I don't have any alignment here, but I will put piece of paper like this, like roughly where I want the board to be aligned, so this yellow one will be the... And there are a bunch of limitations to this process. Like, first of all, there is lens that is collimating the light from the LED, but it still will have some angle, so I should print it a little bit more to the center probably, because it will have some angle to it. Again, not much, but definitely some. Well, actually, I could show you how much probably. Let's do this printing again. So this is how it looks. It's pretty good actually, so that's fine. So what you could do probably, there are some holes in the printer. This is for the tank, but you can use this to make some sort of alignment fixture, which is a very good idea to do, but especially if you want to make some pipeline for this process. And the final thing is, this is the LCD itself. Like, there is not much under it. I don't think it is supported very well, so you don't want to exert very much pressure on it, but this also means that your PCBs must be very flat. So if I put this one here, it needs to be pressed down a little tiny bit. I will peel off this cover, put the PCB down. Also, this LCD is very slippery, as much of the modern phones are. Like so. And to put some weight on it so it is flat as possible, I will use this bottle cap. And so I will block the sensor, press print, and here we go. The exposure time for this machine is 80 seconds. I think it's fine. I kinda did like test pattern, but yeah, 80 seconds should be fine. And when this process will finish, the platform will want to go somewhere, so you need to like stop it from moving. But there is quite big delay time. I mean, you can configure these things, so that should be fine. Again, it's best to make some pipeline for this, so the behavior will be predictable and you will not have to do like any significant manual things during the process, at least. Alright, so layer is done. I will stop this. Alright, so I will turn this off and we can develop the board. The development and etching process is fairly standard, apart from me doing it in the kitchen on the plate, but yeah. Oh! Well, that should be good enough, I guess. There are nasty scratches coming across here, so these USB 3 lines are maybe like damaged, but hopefully this won't be too problematic. We'll see. Since this board is 90% mask, I will try the trick that you suggested to me to add some surfactant. And it is not acting very well, I must say. Yeah, it is much worse than it was before. Yeah, the scratches are definitely quite pronounced. I don't think this will be very good, but for testing it's fine. Okay, it is time to review the board, but I guess before I do that, let me do some kind of calibration. So this is USB-C, there's not much going on really. I mean, there is differential pair with like quite a clearance here, and I think this looks okay. Like at least it's etched and stuff. Then it goes down, down, down. And there is some skew correction, and finally here. So this looks fine. Let's check this HDMI. This looks pretty good, I would say as well. It looks very nice, and USB 3. Also pretty good. The thing to look at is also this connector, because it can be over or under etched. It looks fine. There are these nasty scratches. I don't know. Usually these boards are like 95% of them are fine, but there are some bad bad boards. This is cut line, and it is not etched completely through, which is not great. But like it's very hard to tell by naked eye. This is the other connector. It looks very fine, but overall I think this is fine. This is very, very nice. Yeah, this is some ugly stuff. I'm not sure what happened here, but this island is at least isolated, so this would work. But it looks like I will have to do inspection on these boards when I will etch them. So this one looks pretty good. Yeah, absolutely. Oh, here is also... oh, it's not. It's probably fine. I mean, this looks like a bit of copper there. And here. Yeah, so I should definitely inspect this before I remove mask. But otherwise, this looks wonderfully. And this board used 100 micron track spacing. So you can see how that looks. These pads are definitely over-etched, like they are much smaller than they should be. And the reason why these pads are over-etched, you see, it makes difference how you etch this board. Like if you etch it this way, the space between them will be very slow to remove, but space between these tracks will be removed very quickly. So you want to etch basically perpendicular to the track layout. Okay, so I think this is pretty much all I wanted to talk about. I mean, I could yap for a few more days probably, but yeah, when I will be doing some real stuff with this, I will probably make a video about that. Alright, see ya.